Welcome everyone to a new online-only CocoaHeadsNL meetup. Glad you're still here with us. Hopefully we'll get to see each other in person again soon. For the people that are new to CocoaHeadsNL, we are a monthly meetup group for Apple developers. We are part of the international CocoaHeads and talk about anything Apple related. First of all, we'd like to thank our regular sponsors. They make it possible for us to host our meetups and to record and stream them as well. If you'd like to help us host these meetups yourself, you can do so by getting some swag from CocoaHeads.nl/shop. We have some nice t-shirts or tank tops for the summer, phone cases, bottles and much more. Today we will be giving away 2 JetBrains licenses for any of their products, which will be valid for a full year. You can enter the raffle by simply entering the Meetups channel on the CocoaHeadsNL Slack at cocoaheadsnl.slack.com. If you don't have access to it yet, you can use this invite link. Today, Roel Spruit is going to tell us about working on the CoronaMelder app, which is an experimental contact tracing app that promises to help us fight the growing coronavirus pandemic. We hope you will enjoy his talk. Please keep an eye on our Meetup page and our social media channels for updates on next month's Meetup. If you don't want to miss any of our videos, please subscribe to our YouTube channel. It's the easiest way to see every video that we publish. But we also have our own tvOS app where we will publish every video. I now hand it over to Roel.
Hello everybody, welcome to this presentation. My name is Roel Spruit. I want to talk to you today about the CoronaMelder application, which is a Dutch contact tracing application that's used to fight the pandemic, one commit at a time. I want to talk to you today about a few things. So first of all, I'll give you an overview of what CoronaMelder actually is and how it works. I will show you how it was developed as a team and how it's continued to be developed afterwards, after launch. And I want to share with you some unique aspects of the app that can also help you build better applications. Before I go into this, I have to give a few disclaimers. First of all, I'm standing here on my own accord. Everything I'm saying is my own personal opinion, and I do not represent the opinion of anyone else, either in the CoronaMelder team or in the government. This talk is going to be non-political. There's a lot to be said about CoronaMelder, and a lot has already been said about the app. But I'm not going to go into that today. This is purely about the app itself. And lastly, this app has originally been developed by other people. I'm only in the CoronaMelder app team since October of 2020. Before that, it's been developed by a lot of other developers who have since stepped out of the team to work on their normal jobs again. They did a lot of awesome work but before I ever came onto the team. And I want to tip my hat to them for doing the majority of the work. It's been quite smooth sailing ever since because they laid the groundwork in such an awesome way. So let's start talking about CoronaMelder first. CoronaMelder is a contact tracing application. But what is contact tracing actually? The goal of contact tracing is to find out which people came into contact with people who had a disease, an infectious disease. But traditionally this was not a digital thing. This was just a manual task that was dependent on the infected person remembering who they came into contact with and then reaching out to those people to warn them that they were possibly also infected. Of course, this is quite error prone because it depends on the person remembering all the places he went to. And it's also quite labor intensive on the behalf of the health authorities doing this contact tracing. But now there are technologies like Bluetooth or GPS which make it possible to assist in this process with digital means. So one of those digital means is what's at the core of the CoronaMelder application, which is GAIN, the Google Apple Exposure Notification Framework. GAIN is a framework that was developed by Google and Apple early on in the pandemic. It was actually unveiled in April of 2020. And what it does is it provides a low-level support for Bluetooth proximity monitoring to find out if certain devices were in contact with each other. More about that later on how it works. So it provides OS level support for this contact tracing in both iOS and Android. Apple and Google work together on this to get a very wide coverage of this technology and to make sure that a lot of people can use this kind of contact tracing. What this support gives us as a developer is it gives us a privacy-friendly and energy-efficient way of tracking this proximity from people, but it also gives us an API to build apps that then take advantage of that proximity information, which is in the end what you want, of course, because you want to know and alert people of their proximity to possibly infected people. So here's a short summary of how Gain works. First of all, if you have a device that has the Gain framework and has an app that works with this framework, that phone will then start creating random, anonymous, rotating keys, basically unique identifiers. These identifiers are random and they are anonymous. They also rotate, which means that they are dependent on what time of day you came into contact, which also means that they don't stay the same for very long. So they change every few minutes. These phones then generate these keys and they share them with other phones that they come into contact with in a certain proximity. They basically write down these keys in a sort of local logbook, and in that way you can know which keys you came into contact with. Not necessarily which person, because those keys are anonymous and cannot be traced back to a specific user. So now that you have this logbook, then the actual work of contact tracing can begin. Because if one of the persons that has this logbook becomes infected with COVID and has a positive test, then they can choose through the CoronaMelder application to share their logbook with the public. They basically upload all their unique identifiers, all these keys, to a public location, which is our API. That can then check. Actually, the other phone can then check via that logbook whether they came into contact with one of those keys. And if they did, then we can show them as an application a notification that they did come into contact with a possibly infected person. And then there's a risk calculation done to determine how risky it actually was. Because if you're at a very close proximity to that user, then of course it's much more risky if you were like within 10 meters or something. So this framework was there, and but how does the app actually get built? So this whole road to the app actually started with in April of last year, when the outbreak management team of the Netherlands advised the government that a contact tracing application, a digital way of doing contact tracing, could actually be useful. And an appathon was then organized to find out whether there were parties interested in building such an application, and also to do a feasibility check on this kind of application, if it would actually work, because it actually hasn't been done on such a large scale yet for an infectious disease. Unfortunately, the outcome of this appathon was that none of the parties that joined this appathon were actually meeting all the requirements, specific requirements that the government wanted. So the decision was made to create their own team within the government with outside help from freelancers, and a lot of public companies also loaned developers to this team to get the best of the best working on this app and to build it in quite a short time. Then during the development of this app, they also did a lot of technical tests, which means they want to validate whether this kind of proximity tracking actually worked in practice as Google and Apple said it would. Some technical tests were done in Vught to check that the parameters for this proximity were actually correct. Then in August, the app actually first became publicly available in the App Store, but only with support from certain health authorities in the Netherlands, in certain regions, because this sharing of your public logbook, if you were infected, is actually a step that requires authorization from a health authority, because they don't just want everybody to share their logbooks. They want to make sure that only really infected people do that, so it cannot be abused. And then in October, finally, all the health authorities in the Netherlands supported it, and it actually became an app that everybody could use and download. And actually did. A lot of people downloaded it. So this is what the app looks like with the most basic functionality. It's basically a pretty simple app from the front end. It only shows you whether the app is actually working correctly at the moment. And then if you had a risky contact, it will show you a notification both within the app and as a local notification that you were at risk. And it gives you some options on what you can do now, like get tested or quarantine yourself, things like that. One of the most important aspects of this application was to make it for everybody. And that means that we want the app to be installed on as many devices as possible. And it's because having more people have this app installed makes it more likely that the people you come into contact with also have the application installed. And this is a big requirement to do this proximity check correctly and with enough coverage, basically, in the Netherlands. So we need a lot of people to install it. And interestingly enough, a lot of that depends on accessibility. Now, I'm by far not the first person to talk about accessibility in apps. There are much better presentations surrounding that, but for us, accessibility means literally accessibility. How do I make sure that as many people as possible have access to my app? And I'm not just talking about accessibility like you might know it. So accessibility regarding people who have vision issues or people who are hard of hearing, not just about voiceover and dynamic type, but about many other categories of users that might be limited in using your app. And here's an overview of that. So first of all, one of the obvious ones is we don't only have Dutch speakers in the Netherlands. So we want as many people to install it. We need to make sure that people actually understand what the app is, and a lot of people can only do that in their own language, which might not be Dutch. So we translated the app in about 10 languages and kept that translation going as we continue developing it right now. Then another important aspect is device and OS support. And I'll come back to that in a moment. Then the obvious part of accessibility that you might all know is visually impaired people. So support for voiceover, for larger type, for smaller type, but also for color blindness, of course. So all of those factors were taken into account during the development. Then you have going into some very obscure things that you might not do in your own app. So low literacy levels. There are people who can read just fine, who can see the letters on the page, who don't need a large font to see what's going on, but who actually don't have a vocabulary that's very broad. So you'll have to take that into account by using clear language and very simple language that's easy to understand for every literacy level. Then you have people who can have a great vocabulary but are just not very tech literate. So people who have problems using a phone in general or a computer. Mentally disabled people, of course, that comes back into keeping the app simple. Then you have people who have decreased motor skills, people who might not be able to click very small things on the screen, or might have like Parkinson's disease where you're shaking and where it's harder to use a phone or an app that's not built for that. And then finally we have something called health skills, and I'll go into that right now. Health skills are actually something that's, I think, quite unique for our application, because if you're building a health application, you need to take this into account. So what does it actually mean? Well, first of all, 36% of Dutch people have a problem with finding, understanding, and acting on health information. Which means if you talk to them about health-related issues, they might just not understand because they don't know the jargon, or they're uncomfortable with it. That's also quite possible. So we put a very special emphasis on using very clear language within the app, and where we try to avoid health jargon unless it's absolutely necessary for understanding what's going on with you in a certain situation. Likewise, it's possible that in a situation where you need to inform people that they were possibly infected, that people will get scared of that situation and try to disconnect from it. So we try also not to scare people, and to bring the text in such a way that's non-threatening and very comforting. Now, when you talk about accessibility, we talked about the groups that might benefit from working on accessibility, but there are actually a lot of perks from accessible apps that are not directly related to these user groups themselves. So not just those groups, but also making the app as simple as possible helps the people outside of those groups. So if you make an app simple or easy to use or easy to click or very visually clear, that's not just helping those people who have trouble with those areas of the app. That's also helping all the other people, right? Because a simple app lowers the cognitive complexity of the app for everybody who's using that application. And not just people using the app, but also the people developing the app. So you as a developer can also benefit from the fact that you're making an app extra accessible. By standardizing the language and the text that you use, or using consistent font styling or consistent type, that can really help you to make a clear application when you're limiting yourself in using the correct titles and the correct fonts, and not going all over the place and having to build components again and again because you have one component that's very standardized and also very accessible. That really helps you as a developer to build that app in the first place as an accessible app, but also continue development of that application. Which will in turn allow you to reach a wider audience, which is, well, I haven't worked on any app where this isn't the goal, right? You want your app also to be installed on as many devices as possible. So coming back to device and operating system support, this is quite a special case for us. Because the install base of the app, if you want to reach a wider audience, it depends on a few things. First of all, of course, the willingness for people to install it. That depends mostly on how you publicize the app, if there's good PR surrounding it, if people agree with the idea behind the app. Then of course it depends on how easy it is to go from that willingness to actually installing the app and maybe onboarding. But there's a third point which is actually quite logical, the ability to install it, just the physical ability. And this was a special case for us, like I mentioned, because the GAIN framework, as I just explained, was only introduced in iOS 13, which was the iOS version that came out right after Google and Apple decided to build this framework. Which means only devices with iOS 13 and Plus could use it at the time. And 9% of iPhones at the time didn't even have that OS version installed. So that's automatically limiting the number of devices that can have this app, and that can actually have quite a big impact on the effectiveness of this contact tracing application. So we kind of lucked out in that scenario, because after we launched the CoronaMelder app in October, Apple decided that this feature, the framework, was so important that they wanted to backport it, which is actually the first time Apple has done something like that for a feature. They, of course, backport bug fixes and privacy-related problems very often for older versions, but they haven't ever done that, as far as I know, for a feature. So they added support in iOS 12.5 for the GAIN framework for people who have iOS 12 devices. But this caused a little bit of an issue for us, and when I say a little bit, I mean a big one. Our app was developed with the mindset that iOS 13 was the lowest iOS version that we needed to support. And that meant that the developers at the time made quite rightfully the decision to use the technologies that were handed to them on that platform, which was in this case Apple's Combine framework for reactive coding. But Combine is only available on iOS 13, so that gave us a little bit of a pause in December on whether we actually wanted to support iOS 12. But in the end, we decided to bite the bullet and actually replace Combine with something entirely different. And this was actually the bulk of the work that I've been working on when I came into the team, and was quite a big pill to swallow. So the first step for that was we need to find some framework that does the same thing we do with Combine, but does it in a way that we can also use it on iOS 12. We considered two frameworks for that. First of all, we considered Rx Swift, which is a quite broad used reactive framework, quite well known. You probably already know it. And there's something called Open Combine, which is a framework that was developed specifically for this purpose, for people who wanted to work with Combine, but also wanted to have support for iOS 12 and earlier versions of iOS. In the end, maybe controversially, we decided to go for Rx Swift, even though Open Combine was almost a drop-in replacement for Combine itself. Why did we do that? So we found that Rx Swift is in general a more mature framework. It's been around for a long time, longer than Combine itself actually, and that made it easier to find help and documentation surrounding it. Also importantly, we were currently the developers on that team, but it was likely that maybe other developers would be joining us also, and that might require us to use a framework that's more broadly known, so that developers coming in we have a greater likelihood of them also knowing about Rx Swift. So that was replacing Combine, which was quite a bit of work. We worked on that for maybe a month or so, pretty much full time. Of course, including testing and things like that. But there were other issues with iOS 12 that we needed to work on, of course. So there was no background task framework on iOS 12, which was interesting because the app mainly runs in the background. Once you've installed it, this checking of logbooks actually happens in the background. So we need a background task framework to make the app regularly check these logbooks. Luckily, Apple helped us in this situation because the framework on iOS 12, the Gain framework on iOS 12, had a built-in background scheduling option that allowed us to still run a certain task every now and then to make sure that we could check these logbooks and make sure that we send a notification if people were possibly infected. Of course, we had the different difficulties we have between every major framework update or downgrade, which was certain components were not supported, which was not that much work. But overall, including especially the Combine switch over to Rx Swift, it was quite a bit of work for a month or so. But we gained something very important from that, not just the technical ability to install the app on iOS 12, but also the PR opportunity to say that most people, or pretty much everybody who wants to use the application right now, can use it, which is very valuable for just a reachability perspective. Now, I want to talk a little bit about open source and transparency. Because there were a lot of firsts in this application, this CoronaMelder application, and I think the transparency of it is probably the biggest first in this team. So we were a government team, right? And normally a lot of the government teams work in a closed way, so they develop applications maybe for the government itself. But in this situation, we wanted to be as open as possible because when people had doubts about the usability of the app or the privacy of the app, we wanted to be able to show them what the app was actually doing. And that transparency was super important. So besides just developing the app from an open source perspective, where we allowed people to contribute to it with code, it was much more important than that even, that people saw what we were doing as an internal team, because there was an internal team actually doing the main development of this app. To show that, we kept external GitHub repositories in sync with our own local repositories, which means that we have actually 2 repositories that we sync up every now and then to make sure that the outside world is seeing what we're doing inside, but also to give people from the outside the opportunity to make pull requests on that GitHub repository that we then include in our own local repository again. So we are actually open source, but we still have a main team that is working on the app. But besides the code itself, we actually open source a lot more. So we have the application code, of course, for iOS and Android. We also open source the backend code, where you can see what the backend is doing, how it's storing these logs, how it's comparing how the API is functioning for the app. We have architecture documents which very clearly describe how the entire solution works, from the front end in the application all the way to the back end and to what the GGD or the health authority is doing. So very clear description there on where data is going, how that data is secured, all of those things you can really read out in the open, which is very valuable from a transparency perspective. And then very interesting designs, and also the user research and documentation. So design was shared via Figma. People could actually look into the Figma and give comments on it if they wanted to. And I think that even invited more collaboration than purely on the code side. A lot of designers, I think, helped us with building a super clear user experience for our users. That user experience also includes user research. So before the app was developed, during the app development, we did a lot of research, user research, to find out what people wanted from the app, if people understood the app that we were building, and all of that research and the findings from that research and those usability tests can also be found online, which is super valuable information. Even if you're not working on CoronaMelder or you're working on your own app, it's definitely worth looking into that and seeing what kind of people use applications like this, how people use it, what kind of feedback they have. So maybe some unexpected findings that you wouldn't think of when you're building your own app, like how people use your app, how they use buttons, how they expect things that you might not expect. That's all out in the open, and I would very much encourage you to look at that information. Then, of course, for an app that's so widely used, the quality is like super important. And part of that quality, of course, is the testing that we do for the app. So we ensure that we make a quality app in a couple of different ways. Of course, we have the obvious things like unit testing, where we test the app on a very small level. We then use snapshot testing to confirm that the UI remains like we want it to. We do manual testing of the features we build and the bug fixes we make to make sure that we build it in such a way that it's correct with what we want. Then before each release, we do a regression test to make sure that we didn't accidentally introduce something that's maybe not directly related to the features that we built, but is a regression from the previous version of the application. Then we still, during development, do usability testing every now and then, especially when we're building something entirely new, like the pausing functionality in the app, where you can pause the app when you're working, for instance, as a bus driver. You don't want to get notification from people who were in your bus, because you might be protected in a different way from the virus. So you can pause the application, and that's certainly something we wanted to test, because we want to really make sure that people understand that they turn off the application and that they need to turn it on again. And then we still regularly do some technical tests when we want to determine whether the risk parameters, so the parameters we use to calculate if you were at risk from a certain contact or not, if those parameters are still correct based on the virus as it is right now. So regarding unit testing, I've given a presentation before, I think, about mocking, in which I use the Cuckoo framework, which is a way to generate mock classes based on protocols. But this app already used a different framework, which I actually quite like, so I wanted to talk to you about it today. Of course, when you want to build testable code, I always suggest you start by separating your code with protocols, which makes it possible to test very specific parts of your app and mock, like generate fake versions of all the dependencies outside of that particular feature you're trying to test. And Mocklo is a way of doing that. So what makes Mocklo different from the Cuckoo framework, for instance, or from other frameworks I saw, is that this actually can generate these mock classes automatically, and it does so only based on a annotation that you put directly above a protocol. So if you write down @mockable before a protocol, during build, Mocklo will look at those protocols and automatically generate mock classes from them, which is super useful and very quick. That has the upside that you don't need to write these mock classes yourself anymore. You also don't need to maintain a list of all the classes you want to mock, like you sometimes need to do, like for instance in Cuckoo. But the downside is that these mocks, especially for Mocklo, are quite basic. So you maybe lack some sort of stubbing that you would have in more advanced mocking classes like Cuckoo generates. But I definitely recommend Mocklo. It looks great. If you have any other ways of mocking protocols in your code base, please let me know. This is a topic I'm super interested in, and I would love to know how you do this. Then coming back to snapshot testing, I touched upon it. So snapshot testing is a way, if you don't know it yet, it's a way of regression testing UI. So within the app, of course, we have layouts that are dependent on the resolution of your device, for instance. We have a lot of test devices here, but we don't have all the iPhones, and we cannot test with all iPhones always. So when you especially when you want to test multiple resolutions and multiple screen sizes, it's super interesting to do that using snapshot testing, because it allows you to test a lot of different device sizes very quickly. The same is true for font sizes. So you have larger text, if you have dynamic type support, then this allows you to test that very quickly. So I would definitely recommend doing that. And then finally, you will have a lot of different states of your application. So for instance, we have a state where either the app is running normally or the app is not running okay. For instance, if you have your Bluetooth disabled, which is definitely a state that we want to communicate clearly to the user. So we wrote snapshot tests to confirm that that state always remains correct, even though we might not test it manually every day. Then coming back to helping yourself and being a user of your own app. Helping yourself during development, I think, is something of a superpower. I admit I'm not always the best at it, and I've seen other people do great stuff, but I'm learning, and maybe this helps you also. So first of all, how can you help yourself during development? So first of all, you should really automate everything that you do that is automatable. So if you do boring tasks every day, if you're copying files, if you're doing some kind of work every time you build the application, really you should automate that and make your life a bit easier every day. Another way of helping yourself, which was interesting in this app, which was the fact that we didn't have any analytics or logging in our app, at least as it's in the store, because this was a requirement from the laws that were passed to even release this application. So that really limits you when you have an issue in the wild, right? You cannot ask anybody for any kind of log. You don't really know if people are actually using your application at some point. You don't know how many people are opening it or closing it, or to some level even install it or deinstall it. You get some information from the App Store, but really not on a fine-grained level as you normally would with an application that has some kind of analytics in it. This means that the testing phase becomes even more important for us, because we really want to catch anything we can catch in that phase. We don't have the luxury of finding out in production that something is wrong and then quickly fixing it, because we might not always have the data to find out what's going on. So the way we helped ourselves in that situation was during that testing phase, we really want to help ourselves as much as possible. So we developed a developer menu within the application that's only visible in our debug and testing builds. And this screen really helps us to find out what the state is of an application at any given moment. It allows us to export the logs that we have, at least in the debug and testing builds, to figure out if something went wrong, why did it go wrong, what's the state of the app right now, what was it over the last few days. So giving us that extra information, those extra tools to debug certain issues. So checking the state, and also it gives us the option to mimic certain states. So if we want to mimic the state where you are exposed to a infected person, then we want to mimic that state to make sure that it looks correct, that all the actions that you need to take in that situation still work correctly. So we can really simulate that via this menu, so really changing the state within the menu. Of course, in a lot of applications I've worked on over the years, you have the option of doing things like switching API endpoints, which is also something we can do in the menu. But really going that extra step and really helping you in everyday tasks is really a superpower and a really good thing to have. And I really encourage you to do so. Then I want to talk to you quickly about agility. So obviously this was a very high pressure environment, this development. And we really want to remain as agile as possible to adapt to a quickly changing pandemic. Because our understanding of the virus changed, right? What it was, how it infected people, what were the risks. And then actually even the virus itself changed over time. We got different strains. And then based on those changes, the policy itself from the government also changed. And that policy was mainly reflected in something we call a treatment perspective. The treatment perspective within the app is a page that tells you, what do I need to do now that I got an exposure notification? What are the steps I need to take right now to make sure that I remain safe and that the people around me remain safe? Now, first of all, when the app was first built, these actions were quite simple and hard-coded within the application, because we thought if this changes, we can just release a new app quite quickly and it will be okay. But then this policy started changing, we knew more about the virus, so we required a more dynamic approach. So we built a treatment perspective that was actually retrieved from an API, where if something changed today, we can change it instantly and it will be reflected in all the apps that are in the wild right now. And then going even further, there was new information about infectiousness based on how many days had passed since you encountered a person that was infected. So now we don't just have information that changes for everybody. We have information that changes based on your personal situation and how long ago your contact was. So then we made a even smarter version of this, where we have different types of content for different people based on how long ago your infection was or your possible infection was. And I think this is a perfect example of building something quickly that is adequate for the situation, and then iterating upon it and making it more, not necessarily complex, but more based on the requirements that you have at a point after development. Another way we stayed agile is by remote configurability. So with these apps in the wild, we wanted to have some kind of levers to pull, because we didn't have a lot of control over how many people use the app, but we wanted to have some control over the version of the app that was installed and how the app functions. So how the app functions depends for a large part on these parameters for risk calculations. So this depends on, these are the parameters that we use to determine whether a 1.5 meter distance is risky or not, or whether 2 meters is risky. And this information changed, right? So we definitely made these parameters remote via the API right from the start, because we knew that was going to be a dynamic thing. We also knew that at some point it might be needed to remove some app version out of circulation, because as the app developed, as the virus developed, we knew more about the virus, and we knew maybe that some versions of the app didn't function as we wanted anymore. So we wanted to limit the possibility that there was a bug in the wild, for instance, or we just wanted people to use the latest risk calculation. So by building sort of a kill switch within the API, we have the possibility of having that control. We don't use it often, it's a last resort measure, but we do have it at our disposal, and I think it's useful for a lot of other applications in the wild, so maybe that's something you can configure in your own app also. Then lastly, I want to talk about something very important to us, especially for CoronaMelder, which is security and privacy. Obviously, a lot has been said about this, and I think CoronaMelder goes above and beyond in this scenario in a lot of ways. So first of all, of course, we do regular penetration tests by external parties. So people come and judge our code, judge our applications, to make sure that there isn't any obvious attack possible by people who have malicious intent. But we also benefit in a way from the fact that we're using this game framework that not only we are using in the Netherlands, but it's also being used by a lot of other countries over the world. And we actually have a Slack group with those countries. So we learn from other countries how they use the framework. We also know that if there is an issue with this framework, which is our main barrier of privacy, that Apple and Google will be open about that to us, and need to be open really with everybody, because it's such a prevalent framework. Then we use something called network decoys, which is a common security practice, but not that common that everybody will know about it. When you are infected, or when you receive a positive COVID test, you need to upload your logbook to a public server. Even though that logbook itself is quite anonymous, you won't be able to track who that person is that shared that logbook. The fact that you are sharing that logbook over the network is an indication that you could be infected, because nobody else would upload their logbook. So you're kind of breaking your anonymity in that way, which is why in our application we introduce network decoys, which means that we simulate such an upload every now and then within the app to make sure that just the fact that you're seeing this data going over your network doesn't necessarily mean that you were infected. So we're kind of anonymizing that idea that you are infected just because you share your logbook, which is very interesting, and I think has a lot of applications outside of CoronaMelder itself also. And that's something that's very unique. I think, I'm not sure if this has ever been done, but there's a risk that we as a team have malicious intent also. So I as a developer could introduce code into our code base that's maybe not checked by everybody correctly, and makes it to a production app. And that's why when we release our applications, we make a snapshot of the code base at that moment in time. And that snapshot is then checked by a notary to make sure that the code that we say we released is actually the code that we released. It is quite a unique situation that I don't think exists in a lot of applications. And I don't recommend doing it everywhere, because it's a bit of a hassle, to be honest, of course, making sure that everybody knows which code is released and sending that to a notary. But it's definitely unique to our application, and maybe it's of some use to you. That's my final topic of this presentation. So, of course, there's more information to be found about CoronaMelder itself. I really didn't go into the technical details of how the app is built, and I really don't need to, because the iOS app is open source, like I said. So you can find everything about the iOS app on GitHub. You can also find more about CoronaMelder itself, and maybe download the app if you haven't yet on CoronaMelder.nl. Apple has a nice write-up of the game framework and how it works. Google has a similar page also if you prefer Google. So you can find out more about that, and also look into the documentation of their APIs for Gain. If you want to talk to me specifically, you can find me on LinkedIn or Twitter. And if you want to talk to the CoronaMelder team members that are currently working in the team, you can also reach a lot of us through the Code4NL Slack, which is a Slack that was made by the Code4NL Foundation, which promotes designer and developer collaboration on public government projects. So find us there. Thank you for your attention throughout this presentation. If you want more information, please contact me. I'll see you on the Slack, as we are currently on Slack probably of CocoaHeads. Again, thanks to CocoaHead for allowing me to do this presentation. And meanwhile, thank you for your attention and take care of yourself. Good evening, everybody, or good day, or wherever you are. Thanks for joining me tonight for this CocoaHead presentation. I hope you enjoyed my presentation on YouTube. I'm here to answer some questions about the content of it. I'm looking at the YouTube chat, and I'm looking on the CocoaHead Slack. So if you have any questions for me, feel free to ask them. I'm well aware that it's summer. You can most often find me on the CocoaHead Slack. So I'm looking at the CocoaHead Slack right now, where there's a question from Mario. Did they find a notary who can read code? Yeah, that's a good question. So we have this notarization process where we send our the code that we send to the App Store. We also send to the notary via a GitHub tag. I'm actually not entirely sure surrounding the in-depth process behind that. I only know I send a tag to somebody and somebody checks that that's correct. So I'm not sure if they actually read the code, but they might just do a verification on the binary from the App Store and just check that it matches generally with the code that there is. And I'm pretty sure that they also check that the commits that we do are actually signed, which is another indication that the people who are contributing to the process are only the people who should be contributing to the process and not nefarious people. I'll try to find out how that notary process works in depth. I'm also quite interested in it, but I didn't have time to look at it yet since I started working here. And I'll share something on the Slack if I find out. Thanks for the question. Tom Lockhorst is on the YouTube chat. What types of open source code contributions have you seen, and how many has the team accepted? Well, we have a lot of repositories, and not just for the iOS app, also for all the other code, like I mentioned. I know that for the iOS app, I think we have currently about 30 PRs or something. Some of them were small. I think most of them were quite small, like typos or errors in translation, which is a good thing to have checked, of course, by the community, because if you have weird languages, yeah, we can check some languages if they're correctly translated, but we might miss something in more foreign languages. So a lot of textual changes, I think, were accepted. How many has the team accepted? I think I'm not quite sure. I'll have to check, but at least there were 30. A rough guess for me is about maybe half of those that have been accepted or something like that. The ones that weren't accepted were either big changes that we didn't want to take into the project at that moment. Although they were pretty cool, of course, like super cool animation things and things, stuff like that is interesting for the app, but maybe not as high priority as just letting the app still work as intended. So we also have a few PRs like that. I think we might even have it still open that I have to answer at this moment. That's kind of the open source contribution. And like I said, I don't quite know for the other repos, but I'm quite sure that for the designs, they had a lot of discussion with other designers in the Figma, and not necessarily in repositories, I think. So thanks for the question, Tom. Any questions, other questions hanging around? There's 12 people watching at the moment. I don't know how many people are online on the CocoaHeads Slack. People are still sunbathing outside. It's warm in the Netherlands. I'm not sure if everybody's here in the Netherlands or people watching from outside. What can I say outside of this presentation? Maybe other sneaky stuff to say. Well, of course, I'm just an iOS developer and I didn't do that much work on the Android code base. But of course, the Android code base is also very interesting. I think some pretty high level Android developers worked on that. So be sure to check that out, that code base out also. One of the big benefits, I think, from this kind of open source working, which I haven't done that much in big companies before, is that all the code I write, I can now find online. So that's super nice. So if I leave this project ever, I can just look at what I did in this project, which sometimes you just forget what you did before, right? So you don't know anymore, or you throw the code away because it's a proprietary for the client you work for. So that's the benefit of having it open source. So I hope in some way that this project is some kind of benchmark for some technical challenges that you might encounter in the future, where you can just reference this project, which is super nice. I think, and by all means, I think you can steal some scripts and steal some code here and there if you properly attribute it to the project. So be sure to do that. Any questions still hanging around? Tom, again, it was always good with the questions. Did you have to use the minimum version remote kill switch? I think we used it up to now, since we had it in October of last year. I think we might have used it 2 or 3 times. I think none of the times we used it, we actually used it because there was like a huge bug in the app or something. There were a few situations where we used it just because we wanted people on a later version of the app. For instance, because the app had more specific people perspective, like better instructions for what to do when you possibly came into contact with an affected person. I think we used it in those scenarios a couple of times. So I think 2 or 3 times in the last year or so. It's not too bad, but I don't think we had to have used it yet because it was like everything fell apart or something like that. Thanks for the question, Tom. Questions from outside. Mario has a question. I didn't see it, but Bart shared. Did you share end-to-end tests with Android? I don't think so. I don't think we have any automated end-to-end or integration tests in this project, at least not on the front-end side to our API. It would have been nice, I guess. Most of that integration testing work was manual work. Of course, we do pretty aggressive regression testing on the apps. We just let it run for days on end just to simulate being an actual user of the app, and especially making sure that this pulse, that's the main thing in the app, this background pulse of doing background work keeps running appropriately. But to answer your question, no, I don't think we shared any end-to-end tests other than just test scripts we wrote down for like regression testing the apps. Of course, those are shared because the apps are 99% the same, except for the parts where Android just has a different UI than iOS or vice versa, of course. But all the functionality is 100% identical, so that makes it easy. And also makes it easy as a developer, to be honest, because keeping that in sync is a big help, because if you want to test something, you can just test it on the other platform also. And we found a lot of bugs that way during the development process, which is very nice. Thanks, Mario. Question from Luke Slette? Sounds Belgium or something. Thanks for the presentation. Just a more speculative question. What if you would have all information regarding the spread of the virus from today? Would you develop the application differently? That's an in-depth question. And a bit speculative indeed. Regarding the spread, well, I would say that what's interesting to see, I'm not going to remark on whether we would have done this differently because I wasn't here in the beginning. But what I do find interesting at the moment with this spread is we have a Slack group where a lot of international teams that are working on their own contact tracing applications and who are using the same framework, like collaborate with each other. You see, it's interesting to see all the differences between countries and how they develop different types of applications. For instance, we in the Netherlands, we took this route where we went full on the privacy, and we even passed laws just to have the app in the wild. Other countries are not doing that, and other countries are implementing certain features that we are not implementing, and vice versa. So there is a lot of difference, and in a way, that's interesting to see because you can compare. So how is another country comparing to other countries? But I cannot comment on whether we would have done it differently. The only thing I can say, which is public knowledge, so that's not secret, there's been a lot of scientific research already on contact tracing apps in general, and also our app in specific. There were like professors and universities looking into whether the app actually does what it does, what it says it does, and that all came out very positive. So it is proven by now, with the limited research there was, of course, in the last year, that the app does help in tracing these contacts even quicker, or let's say, if you get a notification from the app and you are already feeling a bit fluish, there's a much bigger chance with those two indicators combined that you actually have coronavirus. So that in a way tells us that the app works. So that's super nice to know. Yeah, that's just something on whether the app works or not. I cannot speculate on would we have done it differently. I cannot say that for you. Other question, Mario Nego Ponzi. That's a different Mario, I think. Thanks. And did you use a device test farm or did you build it yourself? Yeah, maybe something on the internal project tools. We use Azure DevOps and Firebase to distribute test builds internally for Android. And Azure DevOps, I didn't work with it a whole lot before I started working on this project, but I like it very much because everything is integrated. So it all looks the same, which is nice. So you don't have to string different solutions together. But we didn't have a device test farm there. We do have a lot of our own devices, and especially when we started working on this iOS 12 support that I mentioned in the presentation, we bought a lot of extra test devices and shipped them all over the country to all developers because we're quite spread out as a team. Some people are living in Groningen and I live in Leiden, so it's all over the place. So we have all different phone types and at least all iOS first versions that we support. We don't go back that far. We only go back to iOS 12, so we don't necessarily have to test everything. Also, that helps us that the app is quite simple. So as long as the background processes work correctly and the gain framework works correctly, we already test a lot of it. We already tested a lot of the functionality. So we don't have any need for a device test farm in the current situation where we test like, I don't know, 100 different resolutions or something like that. We don't do it. So no, but thank you. Edward Santongo is asking, how do I get an invite to CocoaHeadsNL Slack on YouTube? So maybe somebody from the backend people can invite him. It's a nice place to hang out. I can highly recommend it. Other questions from the public? I don't think there's anything new coming in at the moment. So at this moment, I'm probably going to round it off. I want to thank CocoaHeads for giving me the chance to do this presentation and this Q&A. Like I said at the beginning, if you want to talk to me about the project, about CoronaMelder, sorry, you can find me on Code4NL Slack. For now, I wish you a good night or a good afternoon or good morning, wherever you are. And I hope to see you sometime in the future on a physical CocoaHeads meetup. Thank you.
think about that.